Welcome everyone. My name is Jordi Ricard, and it's a pleasure to introduce a new webinar from our ClearPeaks consultants. Today, we will talk about how to effectively monitor our pipelines in Azure Synapse Analytics and the challenges and innovative solution we've deployed at our customers. With that, it's my pleasure to hand over the session to Alba, consultant in our Azure and Power BI team. The floor is yours, Alba.
Thank you, Jordi. In this section, we'll start by explaining what Azure Synapse is and why do we need to monitor pipelines. After that, I will explain which are the current existing solutions to monitor pipelines. Azure Synapse Analytics is a cloud-based analytics service offered by Microsoft that enables organizations to analyze and process large volumes of data from various sources using a unified analytics platform. This service provides an end-to-end analytics solution, including data integration, data warehousing, big data processing, and BI capabilities. Pipelines are used to do the data integration and to perform ETL operations on the data. Once a pipeline is executed, it can end as succeeded, failed, or cancelled, depending on the status of its inner activities. This is how a pipeline looks like, with its name and its activities. This is another pipeline. You see that these activities can be activities that execute other pipelines, which are the example of this pipeline. So this pipeline contains these two activities, which each activity executes another pipeline. This first activity, if you click on this symbol, you can open the other pipeline, which is this PP operation first half pipeline. This pipeline, inside of it executes 3 other pipelines. So here you can see what we call as hierarchical pipelines, because it's like the level 0 pipeline. These are the level 1 pipelines, and then these are the level 2 pipelines. So each pipeline is executed inside another one. So remember of the concept hierarchical pipelines. Our main aim is to monitor the pipelines so that we can have a global vision of all or specific pipelines. It is important to monitor pipelines so that we can identify any performance bottlenecks or issues with data processing. It is also important because monitoring pipelines can help detect any errors that occur during pipeline execution. All of this is so that we can continuously improve all processes. There are 2 existing solutions to monitor Synapse pipelines, Monitor Hub and Local Analytics Workspace. Azure Monitor Hub is a centralized dashboard within Azure Monitor that provides a unified view of monitoring data from various Azure services, including Azure pipelines. In this user-friendly interface, you can monitor the pipeline run in real time. You can see that using filters, it is possible to track all or specific pipelines. If you click on one pipeline, you can track all its activities to find the root cause of pipeline or activity failure. This feature, you cannot see it in this screenshot, but what I was saying, if you click on this pipeline, you would see which activities does it contain. And Monitor Hub is a good option for developers because you can see the executions in a real time and you know which pipeline you are working on. However, Monitor Hub also has some limitations. It cannot be customized, so the dashboard you see is the dashboard you have. The pipeline metrics are limited, so you cannot create more. Monitor Hub does not have an extensive integration with third-party tools, as Power BI. And it does not give a hierarchical view of pipelines, so it's difficult to navigate from different levels and it is not intuitive. Another existing solution to the monitor pipelines is Azure Log Analytics. It is a powerful tool for collecting, analyzing, and monitoring data from various sources, like Azure Pipeline Logs. It is here where Azure Synapse writes its logs for storing and querying all log data, pipeline logs in particular. By making queries, you can identify patterns of errors and patterns of durations that can indicate performance issues. Log Analytics has also the option to export to Power BI all the data, although this solution is still in preview mode. Once it is connected to Power BI, data is continuously sent and available within 5 minutes, and the resulting Power BI dashboard can be customized. This option, Log Analytics with the export to Power BI, is really close to the solution that we have developed. However, there are many limitations, and that's why we have looked for another solution. These limitations are the following. In order to use Log Analytics, you need to know the custom query language, which can be challenging if you are not used to it. The filtering capabilities are limited, and the query performance degrades when the amount of data collected increases. Regarding the export to Power BI option, you need to have a premium subscription to be able to use it, so you will need to pay more. And only one Power BI workspace can be connected to one Log Analytics workspace. As we have seen, the two current solutions have remarkable limitations, so we have created our own custom monitoring solution. We have used the usual ETL architecture to build the solution. So, when a pipeline is executed, its log is sent to the corresponding blob storage as Parquet files. Using Synapse Analytics pipelines with copy data activities, data from the data lake is copied to a staging table in the data warehouse platform. This staging table is used to create the parent-child hierarchy of the pipeline logs. After some transformations of this staging table are made, we obtain the final table, which we will use to create a view to consume directly from the Power BI, which we will use Power BI to create the dashboard as a reporting platform. To configure the first step of the ETL, the one that sends pipeline logs to the data lake, we used the diagnostic settings from the Log Analytics workspace to configure the exportation of logs in order to archive them to our data lake, which is a blob storage account. You can see in this image that you can choose which storage account to use. So, which are the benefits of our solution? We have many. You can find patterns between pipeline failures and specific days using a calendar. This calendar you will see that is very visual to find patterns of like this type. You can find pipeline duration trends, and it is easy to detect any possible performance problems. Our solution do have the drill down capability to investigate pipeline issues from hierarchical pipelines. We have improved ETL governance since different Synapse workspace can be centralized in one Power BI dashboard if needed. And we can see in a direct way if a process has failed, although Synapse says it hasn't. This is useful for orchestrator pipelines, so that if one inner pipeline has failed but the orchestrator pipeline hasn't, we don't want to have this orchestrator as succeeded. So this is an improvement also from Azure Data Factory. The Power BI dashboard is user-friendly and it's 100% customizable. The unique limitation is that this dashboard is not in a real time. However, as our objective is to create a dashboard so that we can have a global overview of all processes, this is not a real limitation. And let's jump to the demo. Here it is the dashboard that we have created. I will start explaining this first page, the general page, and then I will explain the rankings page. First, let me filter the date slicer by this month, so we can just look at March information. And we could also filter for some other pipelines. So the information that we are seeing now, in general, is the information about the level 0. It means information about orchestrators. So these three, they are the same as these three. These three are the ones, the pipeline orchestrators that we have executed in March. So this calendar, what it says is that if it's green, some execution has been made on this day, and if it's green, is that all executions have been successful. But if it's red, some execution has failed in this day. So we see that on March, these are the days that some pipelines have been executed, and that on the 15th and on the 24th, some pipeline has failed. Okay, we also have the KPI section. These two KPIs refers to the parent execution. So this level 0 pipelines that we are seeing now, it means that during March, 12 executions have been made for these pipelines. If we filter quickly for this one, for example, we see that this logistics top level pipeline has been executed only 5 times. Okay, and well, I can continue explaining about the same, but with this filter. Okay, so we see that this second KPI, what it says is that none of these 5 executions has failed. And for example, if I change to this one, we see that there have been 3 executions of operations main orchestrator. One of main orchestrator has failed, but 2 executions have failed overall. So what it means overall? Overall means not only this first level, this level 0, so this orchestrator, but also the pipelines that this orchestrator orchestrates. So let's study, for example, this one that I just filtered before. I'm sorry, I have something, okay, like this. Yes, now. Okay, so now with this filter on, we see that there's nothing that we can say. Everything looks great because everything is green in the calendar. We see that this pipeline, this top level pipeline, has been executing during this week. It has been executed 5 times and no pipeline has failed. So everything is fine. I think I haven't said it before, but this visual, what it's showing is the last execution in March. So the last execution of the logistics top level, it has been on Friday the 24th. And we see that the status, the global status of this process is succeeded, and everything, and it has durated 37 minutes. And regarding the duration, the pipeline duration, we see that for this pipeline, there's nothing to comment because it's more or less the same duration every day. So it's like, this is like the ideal case, that everything looks green and everything, and there are no outliers in duration. So let's study another one. Let's say, for example, this one, this finance top level. Okay, the first thing that we see is that this pipeline, it's only executing on Wednesdays, and we see that it has been executing 4 times, and its average duration is 35 minutes, and that only has failed once this top level, and we see that it has failed on the 15th of March. So let's start by seeing what has happened on the 15th. So we can select this day and just go to see its details. So we see that this level 0 top level pipeline, it has this level 1 pipelines inside of this pipeline. So finance top level orchestrates these 5 pipelines, and we see that most of them has succeeded except for the middle level. So we can just click on it and we go through, we go to the pipelines that finance middle level orchestrates. So we see that on the 15th of March, the one that has failed is not the aggregated one, but the bottom level one. And we see the error message that Synapse is giving us. It's this one, that operation on target, truncate, table, customer, etc. So this is the cause of this top level pipeline failure. And now that it's highlighted, we see the path that this hierarchical pipeline has. So top level orchestrates middle level, which orchestrates bottom level. Okay, so let's go back to the general page. Okay, so in the pipeline duration, we see also that, as I said before, the average duration is 35 minutes, and in this point, it has rated less than 20 minutes, which is the 15th of March. So we already have seen that the pipeline has failed here, but we can just go to the duration details. So we see how long have been during these pipelines, and we see that the pipeline that has failed are the red ones, and the one that has failed is the bottom level one, which has rated 2 minutes. And we also have this tooltip, which you can see the start date and end date of the and also the error message of this pipeline. So let's go back, and in this graphic, what we also see is this outlier here, which is like the opposite case. So it has rated a lot because it has rated almost an hour. So let's see what has happened here. We can just go to the different levels, and we see that the one that has rated most in level 1 is this middle level, but in this level 2, the one that has rated most is this bottom level. And now that we are here, we see that, okay, everything is green, the status is succeeded, but we also have the information about the execution, so the start date and the end date of this execution. With this information, we could go to Monitor Hub, and we could study there the possible performance issues that maybe that has happened in the activities of this pipeline. We can also see the pipelines that finance top-level orchestrates by clicking on this row and going to see details of this pipeline. So if we do that, we now are in the same page in general, but we are not seeing the level 0, but the level 1 pipelines. So the pipelines that finance top level is orchestrating. We see that in the pipeline duration, the middle level is the one that is causing this outlier here, that is the same as we have seen before in the other page. And we can also go to the middle level and see which are the pipelines that middle level is orchestrating, which are these 3. And we see that in this day, here we can see that the one that is doing this outlier is the bottom level, and we see that, okay, the last day it has rated 2 minutes and everything is okay, but if we click on here, we see that it has rated almost an hour. Okay, so everything is explained about the general page. Let's go now to the rankings page. Now I'm going to make a stop. I'm going to stop a little bit, and I'm going to explain the 2 scenarios that we want to see in this page. So there are two things to know. The first thing is we want to study the main level, so the main orchestrator pipelines, because we want to have like a global overview of all processes. So this would be being the level number is 0, and here we would have information. I'm sorry, I'm going to not select any main pipeline. So here we will have information about all orchestrators. These are rankings about all orchestrators. But if we want, the other case is to study the last level. In this last level pipelines, what I want to say, what I mean about last level is because we want to know how this So at the end, the pipelines that that perform ETL processes are the last level ones. So that's why we want to track all the information about these last level pipelines. So the information that we see is the same for the level 0 than for the last level. I'm going to explain this page by clicking on the last level. So here we have these 5 different visuals. The first visual is the top 5 of the longest executions, ordered by the duration. So here we see the executions listed, and we see that this one is the longest one. And if you notice, is the one that we have been looking for, the 8th of March. And this has durated a lot. But a lot is a relative concept. So why is a lot? Because the average duration of this pipeline is 23. So the percentage of deviation is more than 100, and this is a problem. However, for example, the second longest execution is normal that it's a half an hour, because we see that the percentage of deviation is like 0. So here is a way to compare if the duration of the longest executions is usual, it's okay, or not. And in this section, in the other half of the dashboard, we have 4 pipelines. We have 4 visuals. The first one is the top 5 of the most failed pipelines. The second one is the top 5 of longest pipelines ordered by duration. The third one is the top 5 pipelines ordered by the global duration. I mean, in this month, the pipelines that if you sum all the durations, the ones that durate more. And to end this page, we see here the top 5 of the most executed pipelines. Okay, so it's time to the conclusions. So to sum up, here it is a table with the benefits and limitations of each solution to monitoring pipelines. Our solution has high usability, since users only need to know how to read Power BI dashboards. However, to use Monitor Hub and Log Analytics, it is required to have some technical expertise in some fields. In our solution, as well as Log Analytics with the option to export to Power BI, a customized dashboard is created. However, to use the Log Analytics dashboard, you need to pay a Power BI premium subscription. We can track all or just one specific pipeline using filters with all solutions, although filtering is limited with the Log Analytics solution. Only in our solution we can have the global process status. I mean, that we can see if the orchestrator pipeline has really succeeded or not. And also, only in our solution, it is intuitive to navigate through different levels of hierarchical pipelines to investigate pipeline issues. With our solution and with Log Analytics, it is possible to identify patterns of errors and performance issues. But with Monitor Hub, it is not possible to find such patterns. It is not necessary to make any queries in our customized dashboard, neither in Monitor Hub. However, it is necessary to know Custo query language for the Log Analytics solution. Another benefit of our solution is that we can have centralized logs from different Synapse workspaces, while in Monitor Hub it is not possible, and with Log Analytics can be done, but only in a single Log Analytics workspace. We said before that the only limitation of our solution is that data from our dashboard is not in a real time, while in the other solutions it is. However, our solution is the only one that does not have any limitation in having historical data. Regarding the cost of the solutions, Monitor Hub is free because it's included in Azure Synapse, but it does not satisfy our goal to have a global view of the pipeline logs. So our solution is the cheapest option because it's the only cost that has is using Azure Block Storage, which is not that expensive. And Log Analytics is a pay-for-use option. So, moreover, if you want to use the Power BI connection, then you need to pay extra for having a premium subscription, which leads to being the most expensive option of them. So what's next? We can add more information about pipelines. Since it's useful to know which tables are using the pipelines as the source and destination, because a typical case is to track one destination table in particular, we can add this information to our solution with these two options that you see on screen. Here is an example of how the dashboard would look like, adding a destination slicer. And that's all for today.
So again, thank you everyone for attending this webinar. We will post it in our blog and will be available online. And thank you, Jordi, Alba, Manuel, for this webinar, and see you soon in the next of our sessions. Thank you very much.